Hi guys, here is a video on some of the more introductory problems for special right triangles. Okay, so what we have learned is that our special right triangle ratios look like this. So if we have a 30, 60, 90 triangle, what these often look like are, or not often, always if you have a 30, 60, 90 triangle. If this is A, this is 2A, and this is A root 3. So the side opposite 60 degrees is A root 3, the side opposite 30 degrees is A, and the side opposite the 90-degree angle or the hypotenuse is 2A. So one way we looked at that was we kind of set up a little kind of table, and we had 30, 60, 90. And so then the side opposite the 30-degree angle was A, the side opposite the 60-degree angle is A root 3, and the side opposite the 90-degree angle is 2A. Okay. Then we have a 45, 45, 90 triangle. Now, again, these come up a lot in math, and so that's why they're special. Okay, so for 45, 45, 90, it's important to note that both of the legs are always going to be the same. So if I call this A, this also has to be A. And that makes a lot of sense because if this side is created by a 45-degree angle and this side is, they have to open up at the same amount. If these are both A, then this is A root 2. The table that we look at for this one is 45, 45, 90. And the side opposite 45 is A, and then A root 2. Okay, so those are things that we need to memorize, we need to know. And the whole point of using special right triangles is that they can be a shortcut. So memorizing this is pretty important. Okay, so here is a basic problem. So if we have this triangle, okay, this is our 30-degree angle, this is our 60-degree angle, that's our 90. We're going to call this X, we're going to call this Y, and we're going to call this 1. And so our job is to find X and Y. So what I typically do is there's a couple different ways to do this, but one of the ways is to set up my table, okay? So I have a 30-degree, a 60-degree, and a 90-degree. And then I know from up above my regular tables, okay? And what's nice about this method is it doesn't really matter the orientation because you can always go opposite. So we know that for this from up above, we have A root 3, 2A, okay? But now we need to relate that to what we have. So the side opposite my 30-degree angle is 1. My side opposite my 60-degree angle is Y, and my side opposite my 90-degree angle is X. So then what I want to do is I want to kind of think of this as an equal sign and think, do I have either of these with variables in only one? And the answer is yes. It's right there. And my goal is to find what A is. If I know A, I can find all three of my sides. And that's what I'm able to find first. So if A is equal to 1, then we can find that Y, because Y equals A root 3, and A is equal to 1. So Y equals 1 root 3 or root 3. Okay, so I'm going to call that root 3. And then I can do the same thing with this one. Okay, so if X equals 2A and A equals 1, then X equals 2 times 1, which is 2. And so that becomes my answer. Now this is basic because we're given what A is, or we can find it really simply, and then we solve for the other sides. In the next video, we're going to look at one that's 2 actually that are a little less basic.